Hello students, Unit 5 Electromagnetic Waves continuation video. In our previous video we discussed about electromagnetic spectrum. Okay, here in this video let me see the types of spectrum. Okay, we know when an object is burnt it will emit radiation. Okay, suppose I consider an object. If I burn this, I am applying the temperature to this, it will be emit radiation. Okay, if this object is hot, it will glow in red color. Okay, further I increase the temperature. At that instant it will glow in reddish orange. Then increase the temperature, it is the hottest. Okay, at that instant it will be white. Okay, if suppose this white light is allowed to pass through the prism, okay, white light, this white light is allowed to pass through a prism. Okay, it will split up into 7 constant color. Okay, this phenomenon is known as dispersion. Okay, a white light is passed through a prism, it will split up into 7 constant colors. Okay, this phenomenon is known as dispersion. Okay, due to this dispersion we get a definite patterns of color. Okay, that is known as spectrum. Due to dispersion we get a definite patterns of color. Is known as spectrum. In order to get the spectrum we need to allow the light into the prism. Okay, after dispersion we get a pattern is known as spectrum. Okay, here the spectra is broadly classified into two. One is emission spectra, another one is absorption spectra. Okay, here in emission spectra it will emit definite wavelength. Okay, in absorption spectra it will observe some definite wavelength. It emits definite wavelength. It will observe definite wavelength. Okay, here it is a characteristics of that substance. Okay, here this spectra is a characteristics of the absorbing substance. Okay, it is a characteristics of the source, it is a characteristics of the absorbing substance. Okay, we need to know once again, spectrum is a one that will be delivered from prism. Okay, first let me see what is emission spectra. Okay, emission spectra, spectrum of self-luminous source is taken, we get a emission spectra. Self-luminous source. Example for self-luminous source is sun or incandescent lamp or carbon arc, that are self-luminous source. Okay, is taken, we get emission spectra. I already told, for emission spectra each source has its own characteristics emission spectrum. Okay, then this emission spectra is subdivided into 3. First one is continuous emission spectra. Okay, in continuous emission spectra the light from the incandescent lamp, Okay, incandescent lamp, that means it will glow light when it is heated. Okay, suppose there is a tungsten filament. If I heat the tungsten filament, it will glow. Okay, then this is known as incandescent. Okay, the light from the incandescent lamp is allowed to pass through a prism. Okay, it is allowed to pass through a prism. Then it will split the white light into 7 colors. Okay, here this is a spectrum. This spectrum is a continuous emission spectrum. Okay, because here the spectrum consists of all the wavelength of visible region from violet to red. Okay, we get all the color ranging from violet to red. So it is a continuous emission spectra. Okay, for example we get this type of spectrum from carbon arc or incandescent solid. Okay, the next one, line emission spectra. This is the opposite of this. Okay, for this, the light from the hot gas. Okay, light from the hot gas is allowed to pass through a prism. We get a spectrum having definite wavelengths. Okay, this is known as line spectra or discontinuous spectra. Okay, here these line spectra are sharp lines of definite wavelength. These lines having some definite wavelength. These line spectra arise due to excitation of atom of element. Okay, that is because if suppose I apply energy to the atom, then the atom will transact its state from lower energy state to higher energy state. Okay, up to 10 power 12 seconds. Okay, at that time interval it will come to the origin state. At the time of transaction it will emit the gated energy. Okay, if suppose I apply energy to the atom. Okay, first of all an atom is an ground state. Then I apply energy. Okay, using the energy it will excite to this state. Okay, by absorbing this energy. Okay, after 10 power 12 second, 10 power minus 12 second, okay, it will transact to its original state. At that time it will emit the energy. Okay, that is known as, here this energy, this spectral lines having the energy that is equal to gated energy. Okay, this is known as line emission spectra. Okay, this is arise due to excitation of atom in the element. Okay, then example for this line emission spectra, that is spectra of hydrogen, atomic hydrogen and helium. Spectra of atomic hydrogen and helium. Okay, then the last one is band emission spectra. Then band emission spectra. Here the spectra consists of several number of very closely spaced spectral lines. Okay, here this is a band emission spectra. Okay, it consists of several number of very closely spaced spectral lines that are overlapped together and forming a band. These bands are separated by a dark space. This is known as band emission spectra. Okay, here the band having the sharp edge at one end and fading edge at the other end. Sharp edge, fading edge at another end. Okay, that is here it is a dark blue, then the density of the blue decreases and we get a light blue. Okay, for this is a dark orange, then the density decreases, then light orange, like that. Okay, this is known as band emission spectra. Okay, this is arise due to excitation of molecule. Arise due to excitation of molecules. Okay, in line emission spectra, that is arise due to excitation of atom in the element. It is due to the excitation of molecules. Okay, using this we can study the structure of molecules. Used to study the structure of molecule. Okay, for example, for the spectra, that is spectra of hydrogen gas, ammonium gas. Okay, hydrogen gas and ammonium gas in discharge tube. Okay, then absorption spectra. Okay, we know in emission spectra it will emit definite wavelength, in absorption spectra it will observe definite wavelength. Okay, let me see what is absorption spectra. Okay, when the light is allowed to pass through a medium or absorbing substance, then the spectrum obtained is known as absorption spectra. Okay, when light is allowed to pass through a medium or an absorbing substance, then the spectrum is known as, the spectrum obtained is known as absorption spectra. Is absorption spectra. Okay, by using this spectra we can find the characteristics of this absorbing substance. Okay, here this absorption spectra is subdivided into three. First one is continuous absorption spectra. Okay, for this case, if suppose I allowed a white light into a blue glass, okay, then it will be allowed to a prism, then I get a spectrum. That spectrum is known as continuous absorption spectra. Okay, here the white light is allowed through a blue glass, then the blue glass will absorb all the colors in the white light. Okay, except blue, then it will allow the blue light. Okay, then the spectrum from this prism is known as continuous absorption spectra. Okay, then line absorption spectra. Suppose a light from the incandescent lamp. Okay, we know incandescent lamp is a one that will glow or emit light by applying heat. Okay, the light from the incandescent lamp is allowed to pass through a medium. Okay, here I use a cold gas medium. Then that light is allowed through a prism. Then the spectrum obtained through this dispersion due to the prism is known as line absorption spectra. Okay, here we get a spectrum of missing some lines. Okay, some dark lines are present in a bright background. Okay, this is known as line absorption spectra. For example, if the light from the carbon arc is made to pass through a, that is a, here I use sodium vapor. Light from the carbon arc is made to pass through a sodium vapor. Then after dispersion we get a spectrum called line absorption spectra. In this spectrum we get a two dark lines, okay, in yellow region, yellow background, okay. In yellow background we get a two dark lines. This is known as line absorption spectra, okay. Then next one is band absorption spectra. Okay, band absorption spectra. In band absorption spectra, the white light is allowed to pass through a absorbing substance, that is iodine vapor. Then the spectrum obtained from the prism, then this spectrum is nothing but a band absorption spectra, okay. Here in band absorption spectra we get a dark bands, okay, continuous dark bands in bright background. This is a dark band. It is a bright background. This is known as band absorption spectra, okay. This can be observed in if suppose a white light is allowed to pass through a dilute solution of blood, okay, we can consider this absorbing substance as dilute solution of blood or chlorophyll, okay. We are getting this type of spectrum. This is known as band absorption spectra. Then final one, that is the Fraunhofer lines. Fraunhofer lines. Using these Fraunhofer lines we can identify the elements that are present in a sun atmosphere, okay. First of all, let me see what is Fraunhofer lines, okay. When the spectrum obtained from the sun is examined, it consists of large number of dark lines, okay. That lines are known as Fraunhofer lines, okay. If suppose this is sun, this is sun atmosphere, okay. Sun, from the sun light is traveling, then it will cross the atmosphere, okay. Then the spectrum obtained from this light, we get a spectrum is known as Fraunhofer lines, okay. In this Fraunhofer lines we get some dark lines, okay. This dark lines in this solar spectrum is known as Fraunhofer lines, okay. We can compare these lines with a known element, okay. Then we can find what are the elements present in the sun atmosphere, okay. Okay students, today's class is completed and lesson also completed. In today's class we discussed about type of spectrum. There are two types of spectrum. One is emission spectrum and another one is absorption spectra, okay. In emission spectra it will emit definite wavelength. In absorption spectra it will observe definite wavelength, okay. Emission spectra is subdivided into three. One is continuous, and then line emission spectra, and third one is band emission spectra, and the absorption spectrum also similar, okay. In next video let me discuss the one more questions, okay. Thank you.